All right, so in the materials, I gave you a tarball that when you unzip it, you can use tar.xzf, and then the file name, traf.workshop.tgz, and then it'll extract it. And here's the files that I'm in the directory right now. I got some scripts I've written at work or have used, just a few of them where you can play around with them, automate certain things. I also have this mal pcap directory, which will have some malicious pcap files I've collected from sources like Millworm, openpacket.org, there's a pcapper.net, and there's a few other ones. And there's a big one here in this DEFCON 17 that I found, basically the capture of their CTF challenge. So it's rather large. That's why the file's so big. It's over almost 2 gigs. So that'd be something you can definitely play with. Headers, real quick, I have a number of IP and TCP headers, stuff that you might use as a reference. So we'll just use GQV real quick, and then we have an example header. And you could use these with tcpdump if you need to count the bits. You want to get real specific. We also have source code, which if we had time, I was going to take a look at a few things. We probably will not have time for that. And then I had 2 of the best documents I've ever found on the internet on tcpdump filters. This tcpdump advanced filters and the tcpdump filters.txt. These 2 text files, these are excellent. Very technical filters already laid out for you to do all kinds of cool stuff and already detect certain attacks like win nuke, land attack, fragmentation, ping of death, just some really neat stuff done in BPF. So you can just copy and paste those if you need to. I don't really want to try to explain those; they're quite difficult. And then here's this TXV fault directory has traf-gen configurations. These come with the tool when you compile it, so it gives you the actual configuration file that the traf-gen uses when you want to create packets. And we might get a little into that. Okay, so back to the next few items that we're going to cover. Start with basic TCPdump usage. And here, so we're going to be in the traf workshop directory. I'm going to go to let's just go to mal pcap. Any one of these can be used. Let's just use let's try a challenge. I don't want to type those are long names. Let's do openpacket.org. Okay, so here's an example. It's at the very bottom. Let's just use that one. This is Zeus. So we can use tcpdump. Typically, you just want to use NN for do not resolve names and do not resolve port names to the numbers, and as it reads the etc services file, so that they'll save time in capture, especially a DNS resolution. If you do not specify these, it'll ask your resolver to resolve the address for every single packet, and that takes up so much network traffic and so much CPU time. You'll definitely slow your traffic down. You'll probably lose tons of packets during the process. So you never do that. And also, I suppose if an attacker made a breach in your network and you were querying on his IP address and he had access to a DNS server or just a pcap analysis or something where he can see the request that you've made asking for his name server, he would know that maybe you have a network monitoring station because he's actually you're resolving his names if he sees that DNS traffic. So that's another thing. You might not want to alert anybody. So good practice just to avoid that by using -nn. That's almost in every pcap tool you can imagine. So here is I just did a quick pcap or a read. So we use -nn for no name resolution, no port resolution, -r for reading, and there's the output. One thing we might want to, when we only want to capture a few packets, like we want to do a count, let's just grab one. We can get one single packet. Here is a SYN flag set, so it's initiating a connection to port 80 from a local port. This is an ephemeral port, 1032. And if you want to ask for more information, such as IP options and such, we use -v for verbose. And so you can see it gives you a few other options like TTL, ID type of service, offset, the don't fragment bit to set, and then tells you the upper layer protocol TCP, the protocol number 6, the length of the IP header, or excuse me, the datagram, and so on. And if you want to get further, if you want to actually dump payload data, you can specify -x, and then we actually get the hex and ASCII output. And if you want to dump the payload data with the link layer headers, you use 2x's. And now we have lower level stuff. We can use -e, -E, and we can get Ethernet information. Hold on here. So now we have MAC addresses. We get the ether type field, and 0800 is IP version 4. So that's just a basic, really basic introduction to tcpdump. tcpdump, the best thing to learn to use is the man page. Just open it up and then do a / space and a particular option such as frag. Oops. Frag. And you can use -N, just press N to go to the next, and then eventually explains, you can get all the information right here. Fragmented internet datagrams are printed as frag ID, size, at the offset, and you can go in here and further get more information on how tcpdump presents the data. And most of my trying to figure out how something works or how it's presented, what it means, is just from reading this man page. So you can use you can Shift N, capital N, to go backwards to reverse the search for the matches. So it's just a quick thing to do. But basically, tcpdump is all about doing, just like most things. Just get down and use these examples. You'll eventually catch on pretty quickly. Okay, so things about pcaps. So pcap, I think the current version is 2.4, and a pcap file, like any file, really starts with a header. If we do file command, and let's just do this Zeus sample pcap, it says tcpdump capture file little endian in version 2.4, and it gives you a little information. Now, with this, tcpdump looks for that header when it reads a file to know that it's a pcap. So we can do we can cat that Zeus file, let's do -3, and pipe it, just to kind of show you the things you can do with redirection and filtering. You can play around with this. We can use the dash here to specify take standard input from the filter, which is the pipe. So we redirected output from cat to input of tcpdump, and now we can get the same packet. However, if you specify more than one packet, so get rid of this. So everything in the directory, it printed some of the first, it failed here, and it says pcap loop, bogus save file header. So what actually happened is, after we catted the first one, the next one comes in, it reads what it expects to be part of the packet, more data, but it's actually reading the header of the next pcap file. So that way you know that it says, hey, this isn't packet data, this is a header. Well, it doesn't really know that, but it's checked for the packet data and failed. So there's ways around this. And we would use a Wireshark tool called mergecap, probably to combine multiple pcaps and read from a single large pcap. But there's other things we can do, some little command line tricks that I included because I thought they were really neat. So let's just do this one more time. Sorry, I keep hitting keys. Let's do cat, Zeus, 3, and Zeus 2, tcpdump, R, and take our standard in, and here we have that pcap loop bogus header, because it's an actual header of the pcap file, and the tcpdump is expecting data. So we can do a few tricky things here. One, we can use dd to input the file and output a new file, skipping the first 24 bytes. Because the actual the actual pcap header is 24 bytes, so we can skip those. It basically removes that part, and then if you cat the file and the new pcap file without the header, it's just one big stream of data. And you can pipe that into TCP. I recommend trying that. I'm not going to try all these because they're quite a bit to type. Tail, you can use tail to remove 20. It starts at 1, so this would be the 25th byte. So this does the same thing, just another way of doing it. It removes the first 24. You output to a new file, then you cat a different one file, and then add that one that you've modified to change out the first 24 pcap header bytes, and pipe it to tcpdump, and it works. And you can get a little more tricky and use subshells, like these examples with the parentheses. Each one of these are a subshell. And here, let's go to one. Let's look at this one right here. So we cat you can just one stream, cat file pcap, and we take off the first 24 bytes of file 2.pcap because it's coming in. You got the arrow, the redirection in, and then that will be piped to tcpdump. So therefore, it's cat this file, then that file starts next without the first 24 bytes. So it looks like a whole stream of data. And you can keep piping these just like that. Of course, it's really ugly, and I don't know why anyone would want to do that unless they didn't have necessary tools and stuff. Well, that's one quick way you can use the shell to get what you need. Okay, so we saw the 2.4 pcap header. There's a number of different variations. We can use merge cap, which is included with the Wireshark suite, and -F, and it gives you a bunch of different styles of pcap files, different formats. And obviously, the libpcap is the most common used. There's also Snoop, which is used on Solaris systems. You may encounter that, so you can use a program like editcap to modify or change the Snoop file to a libpcap format, which editcap is also included in Wireshark. Okay, so one thing is, have anybody ever used the any listening device on tcpdump? So it listens to all the interfaces on the system. How does it do that? Well, it actually creates a pseudo link layer header, and the format is called Linux cooked. So if you actually find a file that uses the any that's written with it, you'll find whenever you use the file command. Surely I have one in here. Let me let's do file grep for cooked. I don't know if it was capitalized or not. Let's go do that. Nope, not in there. Surely I have one in here. But basically, whenever we did that file command earlier, and it shows a libpcap version 2.4 instead of Ethernet, the Ethernet won't be there. It actually say cooked, which specifies that this was written or read from a link or the Linux cooked pseudo header on the frame level. So in case you ever encountered that, because I've encountered that a couple times where files I couldn't even read because they were malformed from that. And I'm not sure if that is it's harder to write good data like that, but I've encountered a few. And usually just have to remove the files because I can't read them at all. But this might take a while. I assume it's going to find something, but I could be wrong. Okay, so merge cap. Now here I got the example. Here we created a cooked file. You can just do this right now if you're on the network. Just listen to your wireless device if you're connected to the wireless segment, and you can just dump 10 packets. Then you can do file cooked.pcap. So if you're listening on the any, it should show that it's a Linux cooked file. Okay, merge cap. So nobody didn't find anything that completed. That's a bummer. Okay, let me try. Let's see here. Merge cap. All right, we're just going to take. Let's just do all these. Let's do millworm exploits, and we're going to merge all these files into one large file. So we're going to specify that we're going to use the libpcap format, the -F. Okay, and then we specify we'll use a shell expression, which is the asterisk to say all the files in this directory that match the .pcap file format, and we'll write it. Sorry, I'm kind of messing it here. We'll call it millworm COMB for combination .pcap. And let's see here, file millworm. Okay, looks like there it is. I believe those files, yeah, all these little, they're all little files, so it didn't take very long. But you got big pcaps, you can merge them together. And one thing you could do to test your IDS would be to take that combined file or a bunch of them and just replay it on the interface that your snort instance is listening or your Suricata, and then have it, check the signatures on those packets, and that's one way you could test from real-world exploits, assuming that you have the signatures for the things in there, which I've done that already, and there's quite a few on the millworm that, like, my rules, including emerging threats, doesn't ring on, but does cover quite a bit. So, okay, so let's go back to the pcap file. We're just following along, and here, by default, merge cap reads the timestamps. We'll put each one in order, by chronological order. So if you don't want to, and you just actually want to have like a cat-like thing, just add one pcap and the next one on top of it, the next one on top of it, the next one on top of it to one big file, then you would specify A. So it does not take timestamp into consideration and sort all the files by their times. Especially if you're looking at a bunch of files, you might not want that. Okay, statistical data. Let's quickly go through these. CapInfo is a Wireshark tool. So let's go to, I guess we're already here. Let's do, let's go back to millworm exploits. And we'll do CapInfo on a file here. What do we got? Let's do this barcode. I don't know what that is. ActiveX, pcap. And this is interesting because this will give you all kinds of information on your file. The number of bytes, the size of the file, capture duration, when it started, when it stopped. So if you have a pcap file and you want to keep records of things, I recommend using pcap or capinfos. What I actually do is, if you notice the hash is at the bottom and you want to prevent data from being tampered, every time I write a new pcap, I run a script at midnight or so that actually does use capinfos on the pcap file. I write the hashes to a file. I set an immutable bit on that in the pcap file, and then no one can read or write to it, and then we store it somewhere. So then we have a hash and other information describing the file. So if it's tampered with, you may know if you're inclined to look at the data about it. You can also do normal hashing tools too if you don't want all the extra information like SSH sum or MD5. You can just pipe the hash into there, MD5 deep, and barcode. Then we get the hash we can store in the file. So it's definitely stuff that you need to keep for records, and what's the forensic we call it, the chain of custody, I believe. Is that correct? Okay, so we have a few other tools. TCP slice is how you can slice pcaps into different sets. You can get the time and stuff. We're not going to worry about that at the moment. What we will use, if you want to get a quick timestamp, do we even have this on here? Okay, let that run there for a second. Okay. tcpdstat. So let's go to we'll come back to this. Go to our source directory. We're going to compile some code. I got this. I'll find this is a cool tool. tcpdstat. Okay. Okay, it's just a tar. It's not zipped or anything. Let's extract it. Okay, so we're going to go and enter this directory now. Okay, so let's see here. Got the make file. We can cat the make file. Looks pretty simple. So just type make install. It should fail. This is actually from the author's website. There is a bug in this, but I figured out a way to get it to compile. It's really simple. There's a few other GitHub repositories that actually people have forked it and fixed it too, but I just tried this one day and it worked, so I'm satisfied. So hold on, let me get you up to speed here. Okay, so we're in the directory. We want to VI or use another text editor on tcpdstat. Yeah, I believe it's H. Let me look for a specific variable. Packet length into that file. Yeah, there it is. So that's the file we want. Okay, so at line 415, we had -n to get the line number. So let's do VI plus 415 tcpdstat. It put this right here. We changed this to static int, I believe is what I did in the past. Change that line to static int. And then we compile. Yes, we got it installed now. So this is a statistics program that does statistics on pcaps. A little more detailed than capinfo. So it actually looks at traffic rates and ranges and number of connections and stuff like that. So let's go back. The TCP should be in the path. Yes, it is. Okay, make installed. Installed it in the correct directory in the path. So let's go to a malpcap directory and pick any one you'd like. You can do, I'll just go back to mill one because they're working out for me. And tcpdstat. And if you look at the -h options, there's barely any options. So I'll let it go do its thing by default. And we'll specify, let's just do the Zune one at the bottom. I use tab to autocomplete, by the way. And here's some information, basic information. Takes a little bit to look at the output. I recommend doing that. But you get the start time, end time, seconds, average bit rate, the protocol statistics. I hear protocol breakdown gives you the total. Looks like 100% of IP traffic, 100% TCP. So there's only TCP segments in this. We also have HTTP traffic, which is 50%, and the other 50 is the C. I actually don't know what that means. anybody has any idea, let me know. HTTP, actually, hold on, let me check this real quick. tcpdump, sorry. Zoom, let's do a filter, do port 80, port 430. There's no port with it, so let's not secure that S1, okay. But this is one tool I look at, especially for the protocol breakdown. It's very convenient. We'll go on to another one. There's normally these little tools around the web. I haven't even touched on many of them yet. There's quite a few of them. TCPprof is a really interesting one. I believe it's included with tcpdstat, if you install that. But unfortunately on this much older version of Security Onion, it is not there. I was looking for it, I was disappointed. But here, we specify a number of options, print the ports, no name resolution. I wish the man page would share those, I should explain these too. But and we say --P, don't print statistics on ports greater than 30,000. Because if you do all the ports and you have this run on big pcap files, it can take days and it drives me insane. So I try to cut it in half. So we won't do all the 65,536 total. And we read a file in pcap. And then it basically just pushes out information just like tcpdstat, but much more detailed. It gives you rates on where a specific host was talking, and it gives you a percentage of how much of that traffic was in the pcap file from that particular host. So you can narrow down quickly on who your biggest talkers are. Okay, so here are more advanced filters on with tcpdump. Here, these are just ones I just wrote up really quick so you guys can see an example use of combinations here. So here we list on the ETH0 interface, no name resolution, no port resolution, and we specify we only want IP traffic, so no IP version 6, and traffic between host 1.1 and 1.2, but not host 1.254, 253. But of these two, do grab traffic that is addressed to port 80, 443, and 53. So common ports, DNS and HTTP and HTTPS. And if you don't want to, you'll need to use these when you get in the ands and use the parentheses. You'll need to use the single quotes so that the shell interprets that as is. It comes back to tcpdump. However, if you don't, you can also you can escape the actual the parentheses right here. You can just escape for each one. It depends on what you want to do. If you want to type that out, that's fine too. That does the same thing though. It makes these literal. So you got an escape before each parentheses. Okay, next. Number system conversions. Earlier we used printf for a little bit. Whenever you're looking at pcap files or you need to look for specific ASCII characters, it's best to use or get familiar with a tool called printf. And we basically can convert between number systems. And hexdump is useful to use too. Like whenever I did that tcpdump filter that grabbed the GET request earlier for the web traffic, I used, let's show you my process for that, I suppose. Let's just go back here. I guess I didn't really do that. We'll echo GET, pipe that into hexdump, and here shows the hex value. So we have GET, and 0A is the new line character. So when you press enter, you're actually putting a 0A there. So what we'll do is, since we have in the GET method in the HTTP payload, it actually has a space. So you need that spacer, so put a space and then end it with the parentheses. And now we have the space there. So 47455420. And I would take that, add that to my filter, and do it with the whole hex thing. Find out where the offset is. You can use my those header the TCP headers I included in here, the headers folder directory, and you can look at there and count. Or you can go back to my slides. It was 32 bytes over, and then 4 bytes GET, each character being a byte in the space, and then you find the data. And this, a lot of this you really won't need to know, but it's good to know. You won't actually take that back. You really won't need to use because they're better tools, but it's good to have a fundamental understanding of how everything goes on underneath. And this way, when you're reversing or messing with trying to figure out maybe encoding mechanisms stuff, you can use tools like this to try to figure out what's actually being pressed or what was actually being sent across the wire. Okay, now let's get into session data. Ntop is a really cool tool. I wish, let's see here. I guess I found that. I should have, crap. That was there. Hold on, I'll do that in a second. I found that TCP slice program is in a different directory. Let's do while one, create a little loop here, do ping -c1, Google's DNS server, I suppose. And let's do sleep, 2 seconds, done, yeah, real lame. Okay. Hold on, am I connected? Yes, no I'm not, I'm having problems. I was connected earlier. Let's see here. Let that go for a second. But there, we could actually use Ntop, and it's going to actually show session data flying across. This is really good for live traffic. If you're on a router, maybe not a Cisco router, but like a Linux or BSD router or something, there's traffic right there. We can see communication coming back and forth, and if you have a lot of traffic, it will get ugly. And you want to turn off name resolution, so I press H, it gives you the help, and top left-hand corner, toggle DNS resolution, so I press N, now they're not displaying the host names, which it has to make a request to the DNS server to get the host name, so that makes extra traffic. So, and if you look, wordofmouth.local, it's my host name, it's picking that up from my host file, because typically in a Linux system, the host file is read first, depending on your host settings or your NS switch settings. But so here's this traffic going through. Not very much at the moment. Let's see if I'm. Okay, so we're good. We're sending traffic now. Now, here's extra traffic I'm sending. So here we got a little graph here, and for each time, let's do wget google.com. Here we go right here. There it is. And this is one of Google's IP addresses. Most of us know it. They have this weird name that you might find in your logs. You never wonder what it is. It's actually Google. But on a heavy traffic system, this is very useful. You can easily dig and find out what you want. You can also apply BPF filters, like I can do -F and port 80. Actually, hold on. Filter code. You got to specify. In this one, you have to specify the single quotes. Only want port 80 traffic. It applies a BPF filter to it. Google.com. There it is, right there. So do that. You can also. One cool thing is you can do regular expressions. In the display mode. So no matter, all the packets will come in, but you can do regular expressions on what is displayed. So we can do L, I think it's set screen filter, if you wanted to, whoops, L, grab, 2.168.1. Okay, sorry. Okay, so if you wanted to use regular expressions, you can use a screen filter. I'll do this again. Press L, and you can type in what you want. So you can, like, if you just want things with the word with the numbers 80 in it, should be able to. I did. Hold on here. So let's just do my IP address. Sorry, I haven't done this in a while. The only big downside of Ntop is the fact that you cannot read from a pcap file, which is a bummer. So what you do is you would take netstiff-ng or TCP replay, another program like that, take a pcap file, read it in, push it on one of your interfaces, and then have Ntop listen on the interface in a different terminal window. That way you can do live traffic of previously recorded traffic that you have. You can see it as if it were on your network at a certain period of time, like as if it happened, which is really, really nice. Let me just make a bunch of Okay, so let's do this. I have an article on tcpdump Network Labs on Ntop that has examples of cool screen filters I've used. So if you're interested in that, let's do, here's one. That one worked. It took that one, so it's still showing my addresses. Looking for everything that I have 172.16. So we'll go on to the next one now. I'm trying to breeze through these guys. It's quite a bit of material. All right, so here's a hands-on one. Well, I guess you could all be following along anyway, but this one I have an image pcap here. Hold on. Let's take a look at one of these pcap files. If you guys are curious, when I'm going back and forth like that, I'm using a program called Screen. It's a multiplexer, a terminal multiplexer. It's by the GNU project. So I can use control keys and switch back to multiple terminals. It makes things much easier. Look at that fine. I don't know if that was the window I ran it in or not. No, but I can't fix this. Okay, so let's go into pcap, and we'll go into open packet, and I'm going to do a flow. I take it back. Let's do the def. Well, I think I have that gzip yet. Okay, so you can try these on any of your files. I'm just basically trying to pick one. I don't know what is in what data is in which file, because they're just a collection of online files I got from online websites. Let's do TCP flow though. TCP flow. We're going to read from. Let's try this MySQL worm. Let's see if this has got any good information. No, it does not. Not for flow data. We'll give it colored output though. Okay, so let's go back. Let's take my, here's what I'm going to do. I got an idea. Let's go to mal pcap. Actually, no, defcon. CD, this has a ton of traffic. Everybody want to unzip this on gzip-d, uncompress that, let that go for now. We'll come back to that. Here's the TCP slice. So on this old version of Security Onion, it's in user/bin, so TCP slice. I suppose that's not in the path. User/bin, sbin. Yeah, it's not. User sbin. I don't know why I couldn't complete it. It looks like it's there. Oh, there it is. Wonder why that was. Okay, well anyways, we have TCP slice now. We can use -r, and this is more statistics. You can just get the quick start and stop times. I'm sorry, where am I at? Traf workshop. Back to the home folder. Let's do malicious pcap. And millworm will be fine. And I think it was, yes, let's do barcode again. Active. And here, this is just a quick way to show you start and stop times for the pcap capture file if you don't want to look through cap infos. Okay, so go on the next few things. Let's go ahead and do the forensics. I'm not sure how I'm doing on time. Network forensics, file extraction. So I have a file. Here's one of the ones I was prepared for. Let's do the it's in extract. If you go to the extract directory, there's an image.pcap. And I just basically did a wget across the internet and grabbed this file right here, just whatever I quickly Googled for, and BSD daemon image. And then we can use a number of tools. First, we're going to use TCP flow, and then we're going to run a file carver on it called foremost. So let's just run TCP flow on it. Let me get back to my right window. TCP flow -r image.pcap. Okay, ran it. It gives me two flows, client and server direction, back and forth. So here's the client, here's the server, the reply. So we're going to run foremost, and we see here we specify -v for verbose, and we give it two files. But the reason we need to do this, we need to break up these files into streams. That's what these are now. TCP flow breaks things into flows or streams or sessions, however you want to look at it. There's different terms for sort of the same thing. Because if you run this on a big pcap, foremost on everything, you don't break up the streams. The problem is foremost looks for specific things in the header called an MZ header or an MZ character code set. are they specify the file type, like PDF or HTML or JPEG. They each have their own MZ. If I said MZ code that specifies the file, what type it's going to be. So Foremost looks for these, looks at the start. If to say it's usually a hex character or a few hex digits, say 4 bytes for one of them, and then it'll look for the ending one, and then it takes those and pulls them out. And if you have a big pcap file, it's going to get confused on where's the start and the stop, and it's going to overwrite some of them. It might start here, skip the stop, and end up over here. So if by breaking them into flows, we get the actual files from each stream. So foremost-v 192 and 28. Okay, here we go. Ran, give me some verbose information. It created a directory called output and an audit file, which is basically just displayed above in the output. It just writes this, gives you a record. What you can then do is go to JPEG, because it found a JPEG file, GQ view 001, and we should get the BSD picture. Yay! All right, so here's our first forensic extraction. But this is useful for executables. There is a problem, I believe. There's some hardship when it comes to extracting a PE32 executable. So now you can extract. I don't think Foremost does MP3s, but you can add that in there. There are a number of other tools. Another one would be tcpdump, which basically is a file. Hold on, maybe it's tcpx. Yes, that is it. This is a file just for that, so you wouldn't need to actually break it into flows, and then you wouldn't need to use Foremost. You can just run tcp extract on the file, and it will do the same thing. And this is tunable. You have a configuration file you can specify. You can add your own headers in there by go on the internet, look for MZ header, and you get a file format list of thousands of different file types, and you can add them in there. So what you would like to do, maybe later, you could take this and run this on those exploit pcaps. You might find some exploit, some code, some .c files, or some bad binaries in there, and you may be able to extract those. So, okay, so we're done with that. Let's go to the next one here. I have the example here. If you guys want to do it right off the bat, just specify the pcap file and the out where you want to put it, because it generates a lot of files. I'd recommend creating your own directory, make dir, and then test or whatever you want. Just put the output in there. Okay, so we'll come back to some of these. Let's see here. Okay, that's done. That's done. Let's see if we get anything out of here. I haven't actually looked through any of these, just so you know. It's going to be a while. Let's do. I want some color. There we go. So here, you're actually getting flow data now. You can see a bunch of ASCII art back there that's flowing across the screen. So, some probably C file where a guy put their logo in there. So you can look through flows like that. You can also specify if you only want port 80 flows, just web traffic, what people have done. What's really cool to do is look at FTP connections. Let's try another tool real quick though. TCPpick is another one. -C, -R, CTF. And we can get this to, this is better color output in my opinion, that's why I like using this one. And there's more options. -Y-P will print the data to the screen, the session data. We're not getting anything right now. There we go, there's some of it. I just saw some ASCII art in there. But you can go through flow data like that, and you can filter on what you need. Port 80. That wasn't filtered right. It's big. Looks like you can just specify the filter at the end. So you can try to play with those. Just specify the filter at the end. Give it the single quote and the filter and then the single quote. Okay, so let's try Ntop. I probably should test this one before it came, but like I said before, I haven't really had a whole lot of time in behind. I wanted to have a whole environment set up for this, but I wasn't able to get it due to work and other activities I'm involved in. Let's do Ntop. This is a really quite lengthy Ntop configuration. We won't worry about that. We can just do something basic. Should be able to Ntop. Let's see what I got in here. Something simple as this. This says read the pcap file, specify the port for Ntop to listen on. It's going to open a web interface, which is very useful. and then we're going to use an SSL port, HTTPS on 443. So let's try to do that DEF CON 1. Ntop-r-ctf-w80. And Ntop's a tool that can be demonized. You can run it in the background. Let's see here. No, I shouldn't. Hold on here. I should have tested this. Nope, wrong argument. Whoops. So let's read from the file. Here it is, -F. That's my mistake. So you can change that if you'd like. Ntop-f ctf-w80-3. There we go. Except I had an error here. Okay, let's do let's just put something in there and see if that'll work. If it wasn't, move on to the next one. Oop, oop. Okay, it's working now. Hold on, I'll explain this thing. Ntop, shutting down. Let's see here. Getting a little bit farther. Alright, so let's do well, I apologize. I wasn't expecting this many demos to break. To not work. Yeah, normally I don't have any problem with that. But then again, I'm using, I just booted up, I installed that old version of Security Onion just so I had something to work with. SSL binding problem, there it is. Okay, so it looks like there's probably something already using that port. I hope that's it anyway. I hope that's one of the things. Let's do specify a number that's probably not used. And 1001. Oh, yay. All right, so now we can open our web browser and do Chromium. And this will be reading in the background. This file is rather large, so it probably take some time to read it all. Let's do 1000 for now. There we go. So here we go. Here's Ntop. And here, if you refresh, this will refresh periodically. There's a set time for, I think it's 60 seconds or 5 minutes, one of the two. Total received packets so far, total packets processed. And it gives you length information, bytes, pie graphs of just about everything. Percentage of network traffic. Here's protocol percentages. See, this is 96% odd traffic, so you know that's not good. Or most likely not good. And you got a number of cool settings here. We can go to, let's do the hosts. It actually shows the host that you have communicated with, and then the direction of the bandwidth, ingress and egress. You can see, so the green is the sent, the purple has been the received on the host. You can see who's most traffic hogs on there too. So that's just a quick introduction to Ntop. You got a bunch of other things. You got some plugins, like you can watch ICMP echo requests and other information like timestamps and other stuff. So if you want to monitor that, there's all. And Ntop has the ability to log suspicious traffic you can set up. I think I have that information in one of my files. I might know how to do that. If not, I'll put it something on the website. Okay, so we're done with that one. Bill, how am I doing time? Should I? Because I got a lot of stuff. All right. All right, hold on the wrong window, dang it. I get a little confused when I have so many terminals open.
I got it all recorded. I'm gonna, insert some slides of limb parties and so forth.
All right, yeah. We should have pcaps of lemon party images. That's what we should have. That's what I should have done. Maybe next year. Okay, so let's go back down here. Let's touch on Argus. Argus is pretty cool. I haven't really done a whole lot with Argus. I've just begun, but I kind of regret not seeing this sooner. It is an excellent tool for recording network data, and since it writes it all to the screen, standard out, you can bust out any of your normal Unix command line tools. And all of the big guys that do network monitoring and all that, I believe, use Argus because it's so versatile. It stands for the Audit Record Generation Utilization System. It's written by guys that do this network monitoring stuff all the time. So what we're going to do is we're going to take a pcap. In this case, we're doing all this stuff is offline traffic, or most of the notes anyway. You can have Argus listen on the interface, listen on, and then all the traffic comes in and it'll actually write it to its own Argus format. Let's do mal pcap. Let's do open pcap.org. Let's do Argus. Let's just read a file. Let's just read the Zeus one. 3, and we'll write it to Zeus.argus. Okay, so it's going to take it in. It's going to put it in the Argus file format. Let's just do Zeus.argus, see what it looks like. So it's a DB3 data file, some sort of database. Then we use a tool called RA. And just like Nmap, or excuse me, not Nmap, just like tcpdump, we specify --nr for no name resolution, no port resolution, and read. And we'd read that Argus file that we had just written. And we get flows. So if you have recorded data, one thing I do in my environment is when system load is low, and not, let's say at midnight or 1 p.m. or excuse me 1 a.m. I actually have scripts in the background that take all my daily pcap files and convert them to Argus format, so we can archive them all, and then I don't have to do that later. It's quick. I have them all ready to go. So I just have the script running in the background, say a cron job, and have it just run the Argus and on the name of the pcap file, and have it all automated. I got some of my scripts in the scripts directory also in the trap workshop that I use. So here we go. We have Argus, and we can also pass it filters. It has its own filtering language. You specify RA-NR. And this Zeus stuff looks like it uses, let's see here, kind of missing on the side of the screen. Okay, so this is port 80. Right here we see that the destination, this is the flow going this way. Argus does bidirectional flows. By the way, there's also flows that show you both directions. We can do that file that we just created, that Zeus.net file, sample, Zeus.argus. Specify this dash, it indicates that a filter is coming next, and then we can just do your normal tcpdump port filtering. And there you go. So I suppose if you want, I don't know what other type of information is in this file, so there's that. See, port 443 was not there. So this is where you can do filtering, just like BPF type filtering in Argus, with RA. The Argus tools, RA stands for Read Argus, just in case you need to know, and there's a bunch of them. A bunch. Most of these are Argus tools. Not the Rarion stuff, but you have, let's see here, all these. RA sort, split, stream, strip, RA top, top-light program for network monitoring, a number of them. There's quite a few more. RA graph is especially cool. You can actually make graphs of your traffic. So let's try this real quick. RA graph, I don't know if I have this, let's see here, Zeus. Hold on, let me go back to my notes, make sure I got everything. Here. Let's do a few more first. If you want to specify with RA the -Z option and -B, it'll actually print out the bit set in the 13th byte of TCP header, which is your code field. So your SYN, ACK, push, fin, urge, stuff like that. They're all there. So we can do RA-NNR. Let's grab that Zeus file again. Argus and -Z-B. And let's see here. Start my terminal small. should be able to ED. These over here indicate Ethernet. One thing I'll have to do, I'll come back just a second, RA. I think it's just FLGS flags. Okay, so I want the flags here, FLGS capital. Hold on. There's a, wish I remembered the parameter. But they have all of them in here. It'll indicate, these are all things you can search for. You can detect packet loss in your network as well. There's an option for that. You can find how many packets were lost over a single stream. I thought that was it, but let's give it just a second. Oh, that's a bummer. Okay, so man, let's try Argus. It's in one of these. Unless they don't have that name. Yeah, okay, never mind. Well, anyways, you can, if you look at the demand, there's just so many options here. Let's go back to, let's try this again. Set of specifiers over here. Okay, here we go. Sorry, I guess you have to specify it before. So if you put the option -ZB before, it prints them. So here's the actual flags that were set. A SYN, a push, and ACK, and on the receive side over here, the other side, it has a SYN, and ACK on from the client, and the FIN ACK from the server, so you can get both sides of the connection. Bill, you can kill me anytime, by the way. If I'm going way over, I think. Yeah, if you guys are ready to move on, there's a lot yet. Okay, just let me know. Not a big deal. Okay, so I recommend playing with all these, especially with the R graph. They can be really useful, especially if you want, like for just regular networking, if you want to make a graph of a pcap that looks for packet loss, retransmissions, you can do that, and you can find out, which hosts may have flaky network cables, or which switch, or which host may have bad NICs, and you can graph that, which is really neat. Something I'm gonna try to implement and have it all automated at one point. But let me go ahead and kill out of these. I'm going to show you some scripts real quick that I've been working on. Let's do. I hear this user agent script here. If you use the Bro IDS, I got some Bro examples in the file. I grabbed the yesterday's Bro logs, which is an awesome IDS. It's great. And I use awk and stuff to grab ugly user agent strings and remove the ones that are common, like Mozilla and ClamWin or software update from Apple server or something like that. You can use it for quickly detecting malware or spyware. I recommend making a file with a list of bad user agent strings. You can find a list on the internet. If you just Google for it, I found one that had 1,000 entries in it. You can script that in there and tell it to exclude those entries. So there's a number of things you can do. You can play with this a little bit. I got scripts. IFPPS. Here's what I do. Here's how I write things. Those IFPPS logs to disk earlier. I was showing you how you can you can output to CSV. And here's where I use that --CSV. I do intervals depending on how much the traffic a specific interface takes in. So here I got a number of different interfaces, and I have a script that runs in the background that pulls these and looks for gaps in time where packets were not received that may indicate that an interface went down or a link went down. Then I can see that when my IDS, hey, I stopped receiving packets at 7:30 at night when I'm at home, and it comes and emails me, so I can see if there's going to be any link problems with an IDS system. I got a few other things. Some of these you can look through. Let's see what this is. FPPS. Yeah, here's that same script. This does the emailing. You can use this at work if you want, or for your own time. You can send an email and it does all that. netsniffng. This is how I'm using running 5 instances of netsniffng. Took one out, which is my management interface, but you can bind it to a specific CPU, get better performance. I write logs to the files, or logs to specific netsniffng files that I create. They don't have a logging mechanism right now. Here's the one I really want to show you, this pcap postscript. This, you can suit this to your needs. It actually takes pcap files I run daily, and then I go through them and I cut off the link and I change the names to something that is not a Unix timestamp, which is ugly to read. So it puts like the date, and then it puts if it's a Tuesday or Wednesday, the day, and then it runs it through a bunch of utilities like Argus. You can see here's where I do my Argus conversions. I specify time, I program the write, how long it takes, because I'm trying to get performance in whether I should run them in parallel in different subshells. I run this tcpdstat output on these, tcpprof, all cap infos, like I mentioned. So all that stuff, right there, right there, right there, right there. Then I can come back to it, and then I set permissions, immutable bits on the file in the ext4 file systems and stuff like that. And this just runs in the background, does this daily. Then I can keep an archive of it off-site. I have it all ready to go. But that's it's quite a bit here. So if you want to look around. I think I'm going to wrap it up now. Should be plenty to play with. If you guys have any questions, you come see me. I'm more than willing to talk you through it. You can ask me more detailed questions on things I didn't explain very well and all that. So, all right, thank you.